Welcome to our deep dive into the fascinating world of mathematical cognition.
Ooh, that sounds interesting.
We're going to be using Stanislaus Dehaene's book, The Number Sense, as our guide, and
Oh, great book.
it really is, yeah.
Yeah.
It's incredible.
No classic.
We're going to try to uncover the surprising mental machinery behind math.
Yeah.
Get ready for some insights that go way beyond simple arithmetic, like 1 + 1 = 2.
Right. It's really amazing how much we just take our mathematical abilities for granted, you know?
Yeah.
We're going to be uncovering how even basic math involves intricate brain processes.
Yeah.
From, the surprising skills of animals to the unique challenges that even human geniuses face.
Now, speaking of animals, wasn't there a horse named Clever Hans that supposedly solved math problems?
Oh, yeah. Clever Hans was a sensation in the early 1900s.
Right.
He seemed to be capable of doing these complex calculations and spelling and even musical identification.
Yeah, like a genius horse.
Right, exactly. Committees of experts even thought he was a true genius. But a psychologist named Fungst, he discovered that Hans was actually picking up on subtle cues from his handler.
Interesting.
So like a raised eyebrow or a shift in posture would unknowingly signal to Hans when to stop tapping his hoof.
Oh, so he wasn't actually doing the math. He was more like a mind reader.
Right, exactly.
Yeah.
Clever Hans was more of a mind reader than a mathematician, but
Yeah.
it's still an impressive feat.
Absolutely.
And we probably do this unintentionally all the time with our own pets.
Oh, for sure, yeah.
Giving them subtle cues without even realizing it.
So Clever Hans might have been a fraud, but what about real animal abilities?
Right. So while they might not be solving equations,
Right.
various species actually do demonstrate a sense of what we call numerosity.
Numerosity.
Yeah, it's the ability to differentiate between quantities.
Okay.
So like rats, for example, they can actually keep track of counts across different senses.
Interesting.
They understand that 2 sounds plus 2 flashes of light equals a total of 4 events.
So they're not just reacting to like 2 things. They're understanding the quantity of 4.
Right, exactly. It suggests that a very basic understanding of number might be more widespread in the animal kingdom than we think.
Wow, that's fascinating. It challenges this assumption that math is solely a human invention.
Exactly, and it suggests that this number sense could be a fundamental building block shared by many creatures, even going back to,
Yeah.
our common ancestors.
And that makes me think about human babies.
Okay.
If animals have this innate number sense, do babies come pre-programmed with some mathematical ability?
Well, the famous psychologist Piaget, he believed that babies had to learn math from scratch.
Yep.
But more recent research suggests otherwise.
Mm.
You see, Piaget's tests relied heavily on language,
Okay.
which may have masked babies' true abilities.
Interesting. So the babies might have understood the concept but not been able to articulate it.
Right, exactly. And when researchers devised tests that didn't require words, they made some remarkable discoveries.
Oh, so what kinds of math can these little tiny humans actually do?
Well, babies as young as 4.5 months old show surprise when they see mathematically impossible outcomes.
What does that mean?
So imagine like a screen hiding objects. You place one object behind it, then another one.
Okay.
When the screen drops, there should be 2 objects, right?
Right.
But if there's only one, the babies stare longer as if they're saying, wait, that's not right.
Oh, so they're already getting this concept that 1 + 1 should equal 2.
Exactly. And even before they can speak or count.
Yeah, wow, that's amazing.
And it gets even more intriguing.
Okay.
Their grasp of number isn't actually tied to specific objects or locations.
Okay.
So if you change the appearance of the object, say from Mickey Mouse to a ball, babies still track the number. Their understanding of 2 is already abstract.
That's incredible. So they're not just thinking, oh, there's 2 Mickey Mouses. They're understanding the concept of 2 in general.
Right. It challenges the idea that we learn math entirely from scratch. Could it be that some mathematical understanding is actually wired into our brains from the start?
It's almost like we have a basic blueprint already in place.
Precisely. And this blueprint goes beyond simple counting. Research suggests that we also have a built-in mental number line.
Okay, so like the number lines that we used in school?
Kind of, but this one is mental, and it operates unconsciously.
Okay.
It's how we instinctively arrange things by size, small to large, left to right.
Yeah.
This intuitive sense of order is our mental number line, and it subtly affects how we process numbers.
So it's not just that we learn to associate numbers with positions on a line. we actually experience quantities as having spatial relationships in our minds.
Exactly. It's reflected in our reaction times.
Oh, I'm sorry.
It's much easier to compare 2 and 9 than it is to compare 5 and 6.
Okay.
Because the distance between them on our mental number line is greater.
Oh, that's interesting.
So our brains aren't just seeing digits as these abstract symbols, they're automatically activating this mental number line and processing quantities, even if we're not consciously doing calculations.
It's like we're doing math all the time without even realizing it.
Exactly. And there's even evidence of this in a phenomenon called number color synesthesia.
Oh, isn't that where people experience numbers as having specific colors?
Yeah,
Like 5 might always be green for them.
Right. For individuals with this type of synesthesia, numbers aren't just abstract symbols. They evoke vivid colors and spatial locations.
Wow, that must be such a different way of experiencing math. I mean, what does this tell us about how our brains map abstract concepts if numbers can have colors and locations for some people? What other hidden connections might our brains be making?
That's a fascinating question that challenges our assumptions about how the brain represents abstract ideas, and it highlights just how incredibly complex the brain is.
Okay, so we have this ancient intuitive number sense, this mental number line.
Right.
And yet, as we all know, learning math, especially more complex math, can be a struggle.
Yeah.
What role does language play in all of this?
Well, language is both a powerful tool for mathematical thinking,
Right.
but also a potential source of difficulty.
Okay.
It allows us to express and share mathematical concepts, but it can also introduce complexities that influence how easily we learn.
So it's kind of a double-edged sword.
Exactly. Consider this. Chinese speakers actually have a better digit memory span than English speakers.
Really, just because of their language.
Well, it turns out that Chinese number words are shorter and simpler, which allows for more efficient rehearsal in our mental loop before we forget.
Oh, interesting.
It's not about like brain power, but rather about the structure of the language itself.
So the language can actually give some speakers an advantage when it comes to certain mathematical tasks.
It appears so, and this raises important questions about how language influences math learning more broadly. Could we be unintentionally hindering students by not considering the impact of language on their mathematical development?
Right. It makes you wonder if we could design teaching methods that leverage the strengths of different languages to make math more accessible to everyone.
It's definitely a possibility worth exploring. If we want to unlock the full potential of our mathematical minds, we need to understand how language both empowers and constrains our thinking.
Absolutely. Speaking of how language can sometimes lead to mathematical mix-ups, Define mentions a rather humorous historical example involving St. Teresa of Avila and a calendar change.
Ah, yes. The curious case of St. Teresa's death date.
What happened?
So she died on the night between the 4th and 15th of October, 1582.
Wait, how is that even possible?
Well, it was the night that Pope Gregory III implemented the switch from the Julian to the Gregorian calendar.
Oh,
And to correct for the accumulated drift in dates, they skipped 10 days.
oh, wow.
So October 4th was immediately followed by October 15th.
That must have been so confusing for everyone at the time.
It highlights how even seemingly straightforward concepts like dates and numbers are deeply intertwined with our cultural conventions and language.
Right, so language can make math easier in some cases, but it can also lead to some pretty significant mix-ups.
Yeah.
But even beyond these linguistic quirks, there are certain mathematical concepts that just seem inherently difficult.
Okay.
For example, why is multiplication table such a beast to memorize?
It all comes down to how our brains are wired for memory.
Okay.
We excel at associative memory,
Yeah.
which is great for recognizing patterns and making connections. So
Okay.
like, seeing a lion makes us think of a tiger because they're both fierce predators.
Right.
But this strength actually works against us when it comes to multiplication.
Oh, how so?
Well, multiplication facts need to be distinct and separate pieces of information.
Okay.
But our associative memory wants to blend them together.
Ah, I see.
So instead of seeing 7 times 8 and instantly knowing it's 56,
Yeah.
our brains might get muddled up with 7 times 6 or even 7 plus 8.
Oh, right, because those numbers are all kind of related.
Exactly. We unconsciously add when we're supposed to multiply because our brains are trying to be helpful by making connections.
Oh, that's interesting. So it's almost like our brains are working against us in this case.
In a way, yes, and it gets even trickier.
Okay.
Research suggests that we unconsciously add the digits we're supposed to be multiplying.
Wait, so you're saying that if I see the numbers 2 and 4, my brain automatically thinks of 6, even if I'm not trying to add them?
Well, this automatic addition, particularly with smaller numbers, reveals just how deeply intertwined reading and arithmetic are in the brain.
Wow, that's fascinating. Our brains are constantly doing math, even when we're not consciously aware of it.
Exactly, and it's no wonder that the multiplication table feels so hard.
Right. It really makes sense now why that is such a challenge for so many people.
It's a testament to the complexity of our cognitive processes
Yeah.
and the unexpected ways in which our strengths can sometimes become obstacles.
But these challenges shouldn't discourage us. Understanding how our brains work can help us develop more effective strategies for learning and teaching math.
That's a great point.
So while our brains may have some built-in limitations, by understanding them, we can find ways to overcome them and truly master the world of numbers.
Exactly.
Now let's talk about those rare individuals who seem to defy these limitations,
Yeah.
the math geniuses and prodigies.
Right.
What sets them apart? Is it all about innate talent?
That's where things get truly intriguing. Take the case of Srinivasa Ramanujan, the self-taught Indian mathematician. With minimal formal training, his notebooks were filled with groundbreaking formulas that baffled seasoned mathematicians.
He was like the Mozart of math,
Right.
producing these incredible insights seemingly out of thin air.
And then there are idiot savants.
Okay.
Individuals with extraordinary calculation abilities, but who struggle with other cognitive skills, even basic language.
So it's like their brains are hyper-specialized for math, but at the expense of other abilities.
Exactly, and it challenges this simplistic view of the brain as merely a logic machine. It suggests that there's something more at play, a deeper level of intuition and pattern recognition, especially with geniuses.
So maybe they have a more highly developed version of that number sense we discussed earlier.
It's a fascinating possibility.
Yeah.
One that raises profound questions about the nature of talent. How much is innate? How much is cultivated through passion and practice?
These are questions we'll continue to explore as we delve deeper into the workings of the brain on math.
Right.
But let's shift gears for a moment and look inside our skulls.
Okay.
What can brain scans reveal about what's happening when we crunch numbers?
Brain scans offer a captivating window into the neural symphony that underlies mathematical cognition.
Ooh, that sounds poetic.
They reveal specific areas that light up when we engage in mathematical thinking.
So is there like a designated math center in the brain?
Well, while there isn't a single math center,
Right.
certain regions play crucial roles. One key player is the inferior parietal cortex.
Oh, what?
Inferior parietal cortex. It's located on both sides of the brain towards the back and top. And this area, particularly its left side, is essential for numerical processing.
Okay.
It's active not only during calculations, but even when we simply look at numbers.
Wow, so our brains can't help but engage in some level of mathematical processing, even if we're not consciously doing math?
Precisely. It's like an automatic response.
Right.
And damage to the left, inferior parietal cortex, can lead to significant mathematical difficulties.
Oh, wow. So that really highlights how crucial this area is for our numerical abilities.
Absolutely.
But what about different types of math? Does adding activate different circuits than, say, subtracting or comparing numbers?
That's a question researchers are actively investigating. There's
Okay.
evidence suggesting that different operations may involve slightly different circuits.
Within the parietal cortex?
Within the parietal cortex and other brain regions, it's a complex interplay of neural activity.
Yeah.
And we're only beginning to unravel its intricacies.
So it's not just one brain area doing all the math.
Yeah.
It's a whole network,
Mm.
like a math orchestra, each section playing its part.
That's a wonderful analogy. And as our research tools become more sophisticated, we're gaining a more nuanced understanding of this intricate symphony of neural activity.
I'm curious, what was it like to actually see your own brain doing math? I know you participated in one of those brain imaging studies.
It was truly
What
fascinating.
did they have you do?
They tasked me with repeated subtractions while lying in the scanner.
Sure.
And it was amazing to see those bright spots of activity appear on the screen, knowing that those were my neural circuits firing away as I crunched the numbers.
It must have given you a whole new appreciation for the complexity of what's going on inside our heads, even for something as seemingly simple as basic arithmetic.
Absolutely. It reinforces the idea that math isn't just about cold, hard logic and formulas. It's deeply interwoven with our brain's wiring, our perception, our memory, and even our language.
Speaking of how language and math interact in the brain, I recall you mentioning cases of people with brain lesions who have difficulty with numbers,
Right.
but can still perform some basic math. Can you tell us more about Mr. N?
Yeah, so Mr. N's case is a striking example of the brain's remarkable ability to adapt and the distinct ways it handles numbers compared to a computer.
Okay.
So he suffered a severe stroke affecting the left side of his brain. the hemisphere crucial for language and exact calculations.
So this stroke impacted the same area that's vital for both language processing and precise mathematical abilities.
Exactly.
Okay.
Mr. N lost the ability to read, write, and perform complex calculations.
Oh, wow.
But what's remarkable is that he retained the capacity to compare numbers and perform approximate addition.
Interesting. So, for instance, he can tell that 8 is larger than 5 and could roughly estimate that 4 plus 3 is around 7.
Precisely. It's as if his brain retained a basic sense of quantity.
Okay.
While the circuits for precise calculation were damaged, he was navigating a world of fuzzy math.
That's so interesting.
It's a fascinating illustration of the distinction between approximate number sense,
Okay.
which appears to be more widely distributed in the brain, and the ability for precise symbolic math, which relies heavily on language-related areas in the left hemisphere.
So it seems like there are different levels of mathematical processing going on in the brain.
Exactly.
This reminds me of the split brain patients you mentioned earlier.
Right.
Those who had their corpus callosum severed, what insights do their experiences provide?
Ah, yes. Split brain patients offer unique insights into the specialized roles of our two brain hemispheres.
So, like, the common notion is that the left hemisphere is the language and math whiz,
Right.
while the right is more visual and spatial.
That's a simplified view.
Yeah.
But it holds some truth. The left hemisphere handles most language processing and complex calculations.
Okay.
However, the right hemisphere is not entirely devoid of mathematical abilities.
Oh, really? So while it may not be a math expert, it can still handle some numerical tasks.
Exactly. Studies with split brain patients reveal that the right hemisphere can recognize digits and compare quantities.
Oh, wow.
It just can't name numbers or perform complex arithmetic.
It's as if the right brain possesses an intuitive grasp of math, while the left brain serves as the meticulous math professor.
Another excellent analogy, these split brain studies further demonstrate that our mathematical abilities are distributed across different brain regions, each with its own specialized role.
It's really amazing how these different cases and these studies illuminate the neural basis of math.
Yeah.
But what about those high-tech brain imaging tools?
Oh, yeah.
What can they tell us?
Well, let's go back in time to one of the earliest brain imaging studies.
Okay.
This was in 1931, and it involved a surprisingly low-tech method measuring brain temperature.
Wait, our brain's temperature changes when we think?
Indeed, they discovered that mental effort, including calculations, caused a slight increase in brain temperature,
Wow.
indicating that thinking just like physical activity requires energy.
So our brains are literally burning calories when we're doing math.
Precisely. And that was just the beginning. As brain imaging techniques advanced, we began to create more precise maps of brain areas activated during different cognitive tasks.
Like those colorful brain scans we often see in science articles.
Exactly. Those images are typically generated by PET scans or fMRI techniques that track blood flow in the brain.
Oh, okay.
When a brain area becomes more active, it demands more energy,
Yeah.
resulting in increased blood flow to that region.
So those bright spots in the brain scans
Yeah.
reveal which areas are working hard during a particular task.
Exactly.
So what do these scans tell us about math?
A consistent finding is that mental calculation activates a network of brain regions.
Okay.
This includes the prefrontal cortex,
Okay.
which is involved in planning and decision-making.
Right.
And of course, our number sense headquarters, the inferior parietal cortex.
Right. So it's not just about calculations. It also involves planning steps, holding numbers in mind, and checking for errors.
Exactly. Math engages a wide range of cognitive skills.
And these brain imaging studies have also shed light on what happens when these math circuits malfunction.
Right.
What have we learned about conditions like dyscalculia, the learning disability affecting math skills?
We've observed that individuals with dyscalculia often exhibit reduced activity in the parietal cortex.
So it's as if their number sense circuits aren't firing as strongly.
That's one possible explanation.
Yeah.
And it underscores the importance of understanding the neural basis of learning disabilities.
Yeah.
If we can identify the underperforming brain areas, we might develop more targeted interventions.
It's like personalized math tutoring for the brain.
In a way, yes. And this is just one example of how brain imaging is revolutionizing our understanding of math and learning.
It's amazing how these technological advancements allow us to peer into the inner workings of the brain and unravel the mysteries of mathematical cognition.
It really is.
But all this talk about brain regions and circuits leads us to a fundamental question: what is a number anyway?
That's a question that has puzzled mathematicians and philosophers for centuries. Is a number something that exists independently in the world?
Yeah.
Or is it a creation of the human mind?
It's a concept we tend to take for granted, but the more you think about it, the more perplexing it becomes.
Indeed, one way to approach this question is to examine how mathematicians define numbers. They often employ axioms, which are basic assumptions taken as self-evident truths.
So similar to the concept that a line is the shortest distance between 2 points.
Exactly. And for numbers, we have renowned axioms like Peano's postulates, which attempt to define the properties of natural numbers. But here's where things take an interesting turn.
Oh, there's always a twist. I'm all ears.
These axioms, they beautifully describe the familiar numbers, 1, 2, 3, and so on.
Right.
But mathematicians have discovered that you can create what are called non-standard models of numbers.
It's standard.
Yeah, they also satisfy these axioms.
So you're telling me there are other types of numbers out there besides the ones we know and love?
It's a fascinating concept. Imagine a number line that extends infinitely in both directions.
Okay.
Not just to the right with positive numbers, but also to the left
Okay.
with these artificial integers.
Artificial integers.
They adhere to all the rules, but they don't correspond to the numbers we intuitively grasp.
So they're mathematically valid, but they don't quite feel like real numbers.
Exactly. Dehaene refers to this as the platypus problem.
The platypus problem.
Yeah. Just as the platypus possesses characteristics of both mammals and birds,
Right.
these non-standard numbers fit the formal definitions, but they just seem rather peculiar.
So what does this tell us about the nature of numbers? If our formal definitions can't fully capture what a number truly is, does that imply it's all in our heads?
It suggests that our intuitive grasp of numbers might be more fundamental than any formal definition.
Okay.
We possess an innate understanding of what a number is, even if we can't articulate it perfectly.
So our number sense goes beyond logic and axioms.
Exactly.
It's almost like a sixth sense for quantities.
And this insight has significant implications for math education.
Okay. How so?
Well, remember the new math movement in the 1970s?
I vaguely recall that.
It attempted to teach math starting with abstract axioms and set theory.
And didn't it turn out to be kind of a disaster?
It didn't quite live up to its expectations. Forcing children to grapple with these abstract concepts before they've developed a solid, intuitive understanding of numbers can be counterproductive.
It's like trying to teach someone to play a complex piano piece before they even know the notes.
Precisely. We need to nurture that innate number sense
Right.
with concrete examples and experiences before introducing the abstract concepts.
It's about cultivating a deep understanding of how numbers work.
Exactly.
And that understanding begins with our brains.
Right.
We've evolved to perceive quantity track objects and make sense of the numerical world around us.
And then language provides us with the tools to express these concepts,
Right.
share them with others, and construct more complex mathematical ideas.
It's a remarkable interplay of nature and nurture, biology and culture.
All orchestrated within our brains.
So we've journeyed from animal arithmetic to baby brains, delved into the mysteries of brain lesions and split brains.
We've even explored the mind-boggling world of number-color synesthesia.
We've covered a fascinating spectrum of mathematical abilities, from those who struggle with numbers to those who seem to possess a sixth sense for them.
And through it all, we've uncovered how math is more than just a set of rules and formulas. It's a window into the human mind, a testament to our brain's remarkable capacity to comprehend the world.
If our brains shape math and math shapes our understanding of the universe, it leaves me with a final thought-provoking question.
Go on, I'm intrigued.
If math at its core is a product of our minds, does that imply the universe itself is, in some sense, a reflection of our cognitive architecture?
Now that's a deep dive for another time. It's been a pleasure exploring the fascinating realm of mathematical cognition with you.
Absolutely. We've only just scratched the surface of this incredibly rich and complex topic. To our listeners, thank you for joining us on this deep dive. We encourage you to continue exploring the wonders of the mathematical mind.
Yeah, it really does make you think.
It really does. It speaks to the interconnectedness of our internal world and the external world.
How our minds, through the lens of mathematics, strive to make sense of this vast universe we inhabit.
It really highlights the limitations of our current understanding,
Yeah.
We've explored these incredible capabilities of the brain, but there's still so much we just don't know about the nature of consciousness, the origins of mathematical thought,
Right.
and this ultimate connection between our minds and the universe.
It's a humbling reminder that even with all of our scientific advancements and mathematical prowess, we're still grappling with some of the most fundamental questions about our existence.
But that's also what makes this exploration so exciting, right?
Absolutely.
The pursuit of knowledge. It's a journey without a final destination.
Every answer we uncover just leads to new questions, pushing the boundaries of our understanding further and further.
Well said. And on that note, we've reached the end of our deep dive into mathematical cognition.
It's been a pleasure sharing these insights with you.
And to our listeners, thank you for joining us on this intellectual adventure. We hope you've gained a newfound appreciation for the incredible power and complexity of the mathematical mind.
Remember, math is more than just numbers and formulas.
Right.
It's a reflection of our shared humanity, a testament to our capacity for abstract thought and our innate drive to explore the mysteries of the universe.
Until next time, keep those number sense circuits firing and never stop exploring the wonders of the world around you and within you.